everyone. How are you today? I'm Gil and I'm going to be talking with you for the next, I don't know how many minutes. Brought a dog too. And we'll be talking about, well, not dogs really, dirty and clean tests. Now, I just want to make sure everything's okay. Everything's okay. Why do we do that? Well, there's a lot of experience that I work with a lot of people. I'm going to introduce myself soon. And writing tests takes a bit more than actual magic that they will actually be clean. And then we won't need to look after what the dog is doing right now. So let me welcome you to this session about dirty tests and how to clean them. Welcome to JCon again. Glad to be here. Glad to be invited. First time for me, I think. And a bit about me before we begin. So my name is Gil. I'm a consultant. I work with teams and I train them and I work with them to introduce them to all kinds of things about being a better developer and tester. So testing here applies to both developers and testers. We're going to talk about automated tests. You can clean manual tests, but I'm not sure what the result will be. I'm also the author of 2 books, Everyday Unit Testing, Everyday Spring Testing, and I'm doing all kinds of things. Apart from that, I'm doing a webinar next week about TDD in legacy code. If you're interested, hit me up on Twitter or LinkedIn or whatever. These slides are going to be later on the session description. However, most of them are images, some of them are dogs. They won't help you much, but you can get the examples from GitHub on them. So let's start. So people ask me, Gil, do you write clean tests? And oh, I didn't say before I answer this question, which you'll see on the screen. If you have any questions, please write them in the chat window. I'll try to answer them when I see them. If not, I'll send them in the end and try to get them. Yeah, so Gil, do you write clean tests? And the answer is, man, I do try. It's really hard to write clean tests. And even if you do, and that's true for test and code itself as well, even if you do, you look at your code and your test like 3 days later, and yeah. You see, well, this is what I wrote. It's easier to do this face to someone else. And but usually for my code, that's who wrote that. That was me. Couldn't have done this better. Of course, I could have done this better. Let me try this again. So cleanliness and dirtiness of code and tests are really in the eyes of the beholder. The best way to do that is to get somebody else to look at that. And but even the beholder might be the same beholder like a few days later. Truth is, I do courses about clean code, clean tests as well. It's not only on the eyes of the beholder. It's we apply different standards, even it's the same code. Today we're going to deal with Java, but it doesn't really matter. We kind of look at production code differently than with test code. We shouldn't have this differentiation, but we do. There are a few reasons for that, I think. Most of them psychological. There are no good reasons to do that. But first of all, we don't consider production code as real code as test code. You know, production is real. It goes to production, it runs there. Tests are only useful in some manner and so on. We kind of create our own excuses for that. There's one other thing that when we're trying to at least keep the code clean, is that we have this feeling in the back of our hands that we're going to come here later and we're going to spend time here, fix stuff. So we know we're going to be here, we kind of invest a bit more. With tests, it's a bit different, although we know that the tests are exactly like the code. If something breaks, we go into the test. When the test passes, we see like the green check mark or whatever you're using. It's like we're done with it, and that's good for other psychological reasons. We can focus on something else when we move the next test. But this we're done with it kind of puts this code that we've actually worked with away, and we don't think about it like that. And we look about all the tests that we've written, how many of them are we actually going to get back into? Not all of them. So it's like they don't balance. Then the production code gets a bigger value. And it's true, we don't go back to all the tests, but it's true also that we don't go back to all the code. So in the end, we don't apply the same standards unless you don't keep the code clean, and then you don't keep the test clean, therefore you have the same standards. But we're not talking about these people today, we're talking about us, and we like to keep the code clean. Now, when I talk to developers, which I do a lot, and I kind of shown in the next slide and basically agree that they have, this is their job. Basically, they have the right code that works, whatever definition of works is, whatever they were asked to do, it works. And it's easy to maintain. So what is easy to maintain? So we kind of think, if we take a quick one step behind, we'll look at what we actually need to do. It's not that we need code that works. We provide solutions to people who need it, like customers or internal customers or whatever. And we need to solve problems, and that code solves problems, but it's not a one-time thing. We're going to get back in like next 2 weeks or a month or 3 months, whatever your frequency is, you're going to release another thing that is expected to work. So easy to maintain means we're going to actually be able to do things quickly in order to create the next working thing very quickly. So we actually need to look at this because we're going to get back there. Tests and code are basically, test and production code deserve the same status. Because mainly, if you think about it, it's really about time, the maintainability of things. What is code that works? Code that works means tests prove that. Excellent. What is easy to maintain? Because we'd like to work and produce. We'd like to produce working stuff. We'd like to work on new stuff. And that means easy to maintain means we're going to spend less time in the code or in the tests in order to move forward to something that's working or something that is new, which is much more fun to work with. So when we're investing in clean code, clean tests, clean everything, architecture, configuration, whatever, we're basically respecting the time of either other people or our future selves, and which is much more important than other people, obviously, because we don't like to waste time. We like to create something that works and do it over and over again and enjoy doing that. And the more clean the code and tests, it's easier. So obviously, I've said the word clean once or twice. Let's talk about that. What is clean? So I believe one or two of you have seen this kind of comic before that talks about code reviews. And basically, is your code clean? Like I said, it's kind of a relational thing to look at. It's very subjective. Best way to know if your code looks okay at this point of time right now to this person is have this person in the room. If you don't do that, you're judging it by yourself, and your way of judging it is like I said, subjective. You just wrote the code. Isn't that the biggest nicest piece of code that you've ever written? Of course it is. So yeah, it won't be the objective thing. But again, if you bring someone else, look at the code, there's their point of view as well. So we will never get to objective clean. But let's talk about things that makes code clean. So I brought a couple of quotes before we dive into examples to talk about this. So first one's from Grady Butch, one of the biggest names in object orientation, still works a lot. And he said, clean code is simple and direct. It should be written like prose. Now you think about the code that you've seen today or yesterday. Is it written like a book? Does it tell a story? Well, most of the time it doesn't. Well, it could be like a horror story, but not a coherent one. There's a reason for that, by the way, and we do this in 2021. It was true like 20 years ago, and it was true like even 40 years ago, but the expectation is different. We mix a lot of code of different levels, and we use a lot of libraries which look in their own little language. A lot of boilerplate code, which is another language. We call somebody else's code, which is a kind of another language. So if you're trying to read a story about what the code does, you need to kind of translate all kinds of pronunciation and stuff, hopefully, or languages if it's completely bad. So if you're writing the code, and we're talking about you today, it should be written like prose. You need to tell a story, especially in tests, because tests have a very special story to tell. Michael Feathers, he wrote the book Working Effectively with Legacy Code. I consider it the Bible of unit testing. If you haven't read it, go read it. He said that clean code always looks like it was written by someone who cares. Cares about what? Time. Again, why should I care about somebody reading the code? Well, this poor soul, which can be me, is going to spend time in this code again at some point in the future. I want him or her, be able to complete their tasks, to produce something that works, fix something in order for it to work, move on to something more interesting. I care about this someone or someones, and therefore I write better. We'll show examples of what better means in a few minutes. Martin Fowler, who wrote the book Refactoring, knows what he's talking about, because refactoring is usually considered transferring the form of one type of code to another, hopefully for the better. And if we can write code that the computer can understand, good programmers write code that humans can understand. And it's true. I think a few years ago, I was in a workshop of TDD in assembler. So you can write code in zeros and ones, and the computer will understand it, but we're not writing just for the computer. Because once the computer understands, he said, yeah, it's full on, I'm going to run whatever you give me. Excellent. But the person who looks at the code is not a computer. And programmers have other needs, and they know other languages, and they understand syntax better. And unfortunately, they're human, and they have all kinds of assumption when they read this stuff. So computers very strict. We reads bits and bytes, knows what to do with them. For whatever good or worse it will happen. But humans, yeah, they're problematic. So we'll try to write code that humans can understand. The final thing I want to mention is something that I also mentioned, doesn't say the word clean, but it is by Uncle Bob Martin, who wrote books Clean Code, Clean Coder, Clean Architecture, and other clean stuff. And he also mentions the Boy Scout rule: always leave the campground cleaner than you found it, which means whatever code you go into, make it better. because it's not the final time, it's going to be visited, and we talked about why we want to do that. Right, so we understand clean code, whatever that means. When we know it, we will see it probably. We're actually much better in pointing out what's wrong with code rather than what's good about it, but that's okay. So let's think about what clean tests are. Well, we can talk about a few things that apply to clean tests. So when we look at tests usually compared to other tests, we'll know what's better about them. But let's go through a couple of points that we think we all agree that are, if the tests apply to have these principles on them, they probably are very useful for the process and the goal that we gave ourselves. We want to appreciate time better. So first of all, tests show intent. Tests are examples of how we use the code. And I'm talking about any kind of test. So it could be from unit tests to API tests to integrate any end-to-end tests. We're looking at code that runs other code. And basically, this is an example, regardless of scale, of how to use the code. Specifically, we have more than one test, hopefully, and therefore we have different scenarios, we call them, to run the tests. And scenarios really apply, if you look at it, it's more of a context where we run the test, which could translate to a setup in some way, and the result, because we run the same code in different scenarios, we expect sometimes the same results, sometimes different results. So that's a scenario. But when we read them, we can see, well, this is how the code should be operated. And that's very good, because if someone new comes in the team, that's their example of how to use the code. So that's one thing. Second thing is about focus, and it's easier to understand when we talk about unit tests, harder to quantify when talking about a larger path. But let's take unit test, for example. Why is unit tests helpful? Because it tests this bit of code. If it fails, you know that the problem is here. So the focus about fixing a possible problem in this section is it kind of creates the solution for that. If we have like a end-to-end test, it does an operation probably, and then we can say that if the test failed, the operation doesn't work. What's the problem? We'll have to debug and see what's happening there. If it does a lot of things, like different workflows and spans like 3 screens, we see like, well, we'll ask the question, well, why did it fail? We'll have to investigate more. Did it run this part or did it run that part? So if you're familiar with clean code and the solid principles, there's something called the SRP, single responsibility principle, which means that code needs to do just one thing. It really depends on how big this thing is, but it doesn't matter for now. Tests should be focused as well. And if they're doing too much, maybe we should separate them into different tests, because if we do that, we'll have more information about what works and what doesn't. Again, we're appreciating the time of our future selves there, and we'll do like detective work, like this thing worked, this thing fails. The problem is with this code. Again, shortening the way to working code. Tests should do exactly what they say, and you say, well, obviously, well, if you manage to wait, I bet when you started looking at the first calculator examples for usually what you see in tests, test tutorial, automated test tutorial, you see calculator example, and you'll see the name test ed. Well, yes, it adds numbers, probably. We don't really say, but there are 50 other scenarios of adding numbers in our tests. What does test add mean now? Or something that sometimes create a problem for us. I do that a lot. I start off with a test name saying I'm going to check this thing, and I trail off to checking completely another thing. And then the worst case scenario, I just forget changing the name to what it actually do, which is kind of a common thing. Or not being specific enough to differentiate it from other tests. So we want tests to say usually in the name what they actually do. Why? The way we work is that when the test fails, now it doesn't really import. It's not really important. I'll know what I worked on. I know I've written the test. I know it's not. I know what doesn't work. But next time I see something fails, it's going to be in the CI, in the build report, and saying this test failed. And then again, what we're looking for is not wasting time. And the road from a good name to a solution or from a bad name to a solution really shorten or lengthens the work. Finally, I'm discussed this in the language level, but also and we'll see that in example soon, we're using a lot of third parties, second parties, different languages, and specifically if you're using libraries, if you're using open source code, it's usually very generic because it's supposed to be a solution for everyone, but it doesn't speak your application language. So you're creating a lot of details, and sometimes it's very specific. So you get like a very, it has maybe a very chatty interface. So you have this kind of bulk of setup for the test, which kind of confuses you because these are details and not the details that you may even want, but you read them in part of the test and say, ah, maybe this is important. So we want to abstract implementation details because otherwise it confuses us. If it confuses us, we'll spend more time in the test and therefore less work on new stuff. So there are things like called code smells. You probably know them. There are test smells as well. Let's take a couple and talk of them. God class and God methods are a big code smells, which means that the classes are big, methods are big, and so on. Test classes are kind of a trap because they become a container for all kinds of things, and it's very easy to get to a God class by adding one more test, one more test, one more test, and that may be a problem. It may be a problem because yes, it's easier to know where to drop the next one in, but then if one fails, one and another fail, but in between them they have like 10 things are passing, you don't get the picture of what is actually working. More problematic is that if you have kind of a dependency between the tests, and it's not about the tests that are wrong because the tests are great, but the code is crappy, and it has some kind of shared data that gets passed along between test runs, you don't see that. And it creates a bigger hole for you to come out of. So bigger test classes, bigger test methods create like traps we don't like. Comments in the tests. We don't usually do that, but sometimes they are there. If you're using GeoNet 5, you have display name. That's kind of a comment. The problem with comments is that they outlive their purpose, and we don't get back to fixing them because they compile just great. Same with test names. Test names that may look today okay, tomorrow they will not be that communicative. They compile great, but nobody says if they work or not. And finally, embedded constants. We have a lot of, let's say your code uses a get user by ID number 17. What's so important about 17? Is 17 and 18 alike? Is 7 and 20 are alike? how is it possible for me to know as the reader of the test, what is the significance of 17? And we do that a lot. We use a lot of literals and constants in the test code because it's easy. And sometimes too easy to do that, rather than telling what is the significance of these numbers. So be vigilant about this. Let's take a look at a couple of examples. So still sharing, excellent. So I'm going to show you an example of API tests with Spring. This is a calculator, of course. It doesn't do much, right? We have a controller with a post called calculate. In the body, it gets a calculator programs, which I'm guessing you probably know what this is, and you're probably right. It's this stupid data class. First and second arguments and the operation. The ops are these. Amazing, I know. The consts that you've seen here are the roots for the APIs. And basically what it does is just does the calculation for plus and minus, otherwise draws errors. It doesn't really matter because we're not looking at this code, we're going to look at the tests for it. So let's start. So I've written a couple of tests for this API, and I've written them the way I would actually write. And the way I would write it is one by one. So here's the first test. I called it test add, as one should, and I gave it a comment called check that we can add two numbers and return the right result as a string. Cool, right? And I'm setting up the calculator params, which is 3 plus 4. And then I'm creating the headers and doing the JSON transformation of the calculator params, creating the request, the REST template, and doing the post itself. I'm running, sort of running on the local host and going to this API. And then I check, if you don't, I'm not sure if I showed you, it returns the string of the result. So an assert. And what did I mean by this is how I would write it? It means that when this thing works, I would go on and copy it because it's much easier to do the second test if I have the first test. And you'll see a lot of that in tests. So a lot of repetition of everything. And because it's easier, because this one will pass in like 1 minute after I fill in this, even the plus didn't change, and the result. Oh yes, I can need to add a new name and test add minus, which is not a very good name, I know, but this is an example. And I kept, if I copied everything, I should copy the comments as well. And then another test, I have a subtraction, which you know how I got by copying it and do it. Basically, this is a very, I wouldn't say a good example, very probable example of what you'd see out in the wild. So let's start cleaning this up. The first thing I do is want to remove duplication, and I do it in 2 steps. The first thing is by looking at all the things that I create over and over and over again. So I can do a thing at a refactoring pattern called extract field. So turn these local variables to fields. And the initialization, I put them in the setup method for the tests because it's a common setup. So this is what it looks like. I removed the, I didn't show you. I'm starting off with almost 100 lines of code. The God method complex. So fields are here. Everything almost that I create, the only thing that's left is a JSON. There's the string result here in the JSON. But all the things that I initialize are now fields, and they're created here, initialized here. So that removed some duplication tests becoming a lot better now. Let's continue. The second thing I want to do is look at the names. And this is something we need to do a lot more than we actually do. So obviously, test add setup is okay. Test add, okay, it does add numbers, but what differentiates it from here? So test add minus. Yes, there is some kind of differentiation. We can do much better than that. And obviously better than test minus here, which I put here to confuse the people. So a bit of naming. Also, you could notice that the comments that I put are not that helpful. So let's introduce better naming and no comments. So this stays the same. Now the first test, I called it add two numbers and calculate result. Second, add two negative numbers, calculate result. The third one, subtract two numbers and calculate result. Is this optimal? Well, obviously, and calculate result, some kind of code duplication. It's something that we do a lot when we are writing tests for what we call the happy path or the positive case or whatever other names we use. Obviously, it should do what it does. And we calculators obviously give results, so we can write it there. Can we drop the end calculate results? Probably, but it's something to consider when you're doing all kinds of this kind of tests mixed with negative tests or what other things. Happy case, cool. Happy case I haven't seen before. I saw happy path and positive case, but happy case is cool as well. It's like a mix of everything good in the world. So good names are hard to find, and if you can get rid of the comments and put them in the names, it's probably better. Right, next thing, obviously, we see a lot of duplication here that we can see. So let's remove that. So obviously, the refactoring pattern we call it as an extract method. We'll create a method that calls this. So this stays here. Let's see what happens here. So the tests are obviously becoming a lot easier to read. And by extracting the common stuff out, we can keep the specific stuff, specific for each test, in the test, which is a lot cooler and a lot easier to differentiate when you look at this one's passing, this one not. So we have the calculated params, and I extracted a method called calculate. And at this point, everything here stays the same. So I just extracted it and make it here. Marcel says, I like Kotlin. The test name can be simple text. Yeah, if you use Kotlin, if you're using Groovy as well, if you looked at Spock as a test framework, which is built on Groovy, you can do that as well. If you're coming from JavaScript, I wouldn't say background, but other ground, you have that as well, because the name of the tests are very long sentences that you can put spaces without underscores in them. We kind of mix the, and you have the display name in JUnit as well, JUnit 5, which will be presented as a description. But keep in mind that you might mix, contradict, or whatever between the test name and the display name as well. So this has to be reviewed as well. Where was I? So yeah, so this is here, and I passed in the URL. Display name generation with test underscore class for the week. Yeah, thank you, Sven, for creating a new black hole in the Java development environment. Yeah, excellent. If you look at it, you'll see that all of this kind of repeats itself. So at this point, I didn't see that. I just extracted things and put the URL, which serves all the tests here. It could be extracted to a constant, which will be done in a minute. But if you're using different literals, you probably want to do that. So the next step for me is, first of all, remove this parameter and take a look at the literals. So first of all, I put a local URL here, and it's a point that we'll continue to mention. A local URL is for the tests. We're dealing with tests and in the scope of the tests. When we're running in production on another stage area, it won't be localhost, it will be something else. But this would be the first thing. So I'm creating a literal here, and I'm just using it here. I no longer have the parameter here. It's simpler for the test, really. Again, the common stuff extracted outside, but I can do much better. And that I can use the local URL concatenated with the constants that I mentioned in production, which will make the test less fragile, because if things changes in the URL, in the routes, tests will still pass. Now, the separation between what belongs to the test and what belongs to production helps us maintain it better. What is not good here, and out of laziness I didn't fix it, I should put it in another name, and it shouldn't be going into the local URL. It should be like going into the URL itself. But that's okay. So that's basically it. I've got 2 more steps before I'm finished. Let's take a look at the calculator params. So the calculator params basically now, it's very readable. That's okay. But imagine that you have like a very big setup, like you're sending like a giant piece of JSON in, and or in the body, or you're extracting JSON from the body, from the response, and you want to compare it to something. Now, building this entire JSON thing will take a lot of space, and it will do 2 things. First of all, it will push out some of the important stuff. We talked about seeing the important stuff in front of us, but also out of the, let's say it has like 100 fields it needs to set up. Which of these 100 fields, even 20, are important for these tests, and what can be common in another test, and what is important for that test? So we can't really see. And the answer for that is to use something like a builder. A builder is a pattern, one of the 14 design patterns that are in that very boring book. It's a good book, but it's still boring. So use a builder to build something. What would you build? Usually, in our case, setup data or reference data. So I'm going to do something that probably we wouldn't do, because calculator params is of only 3 fields, but you can see how it references something much bigger. So I'll build a calc param builder. And here in this example, it's part of the test, and that's okay. It's also possible to do multiple builders. I'm going to go what this builder does. For people who don't know the pattern, basically it contains every field it does. Everything is initialized, and this is very important, because if you don't, you start from a skeleton of the default. If you don't need to set something that is already set for the default. So basically it has, I'm using like a Fluent API stuff, so with first, with second, with ops. And then usually you have a build parameter that builds everything it's collected until now. So if I look at my tests, they will look, setup stays the same, but I'm going to use the param builder to build with first, with second. And what you don't see here is without the operation, which is default. So, and that's the plus. In the subtract 2 numbers, you have this with first, with second, and ops, because it's not with the default. Now, some people would say, well, I'm hiding information by not doing the with op plus, and I might agree with them. But if you're building something, I built an address builder, and built an Uruguayan builder, which always set the country to Uruguay, it's not as important as the plus, but does keep the plus thing. Andreas says we need all the fields in deep layered from abstract, for instance, to avoid NPEs. We read it from JSON actually during test from test resources. So that, but you need to do this. You need to manage these resources as well. I once said that builders are easier. You can construct builders out of test data files as well. It doesn't have to be everything from the code. It really depends on what you have. The bigger data stuff that you need to manage, we kind of delegate the work from the tests to the test data. But our point here is to keep at least the tests code easier to understand, because we'd like to know if something is wrong, what happened. I usually in favor of delegating things to data, but keeping the code of the tests cleaner in order to find out the problems earlier. And only when I need, I'll go to the data and see what's happened there. In our world, you want these kind of things like 3-parameter builders, obviously. But redundancy, sometimes it is okay if it makes things readable. Again, who knows what readable is? Only the person who's doing your code review. Final thing I want to show you is this thing here. So obviously the tests work. I've kind of reduced them to all things that are specific. I kind of remove this. But you know that this code, while needed, does it actually belong in my calculator? You don't see that. The calculator test thing? Or maybe it could serve as something more generic. And it is like boilerplate. This is Spring code mostly, which doesn't have anything to do with calculator language. So let's do something like this. Ooh, I missed something. I missed something bad. Something is definitely wrong. Let me see if I can find something. Yeah, something. This is very bad. But okay, what I was going to show you, unless I can fix it. No, I can't fix it. Sorry, not here today. The idea is to take this. Let me show you. Take this and extract this into a separate class that is given the responsibilities of actually going to the server. It can do the post. It can actually do the post, get whatever you want. It will target API call wrapper, I called it in another life, apparently. But apart from that, you separate the code that goes to the server, the platform code, and the application code of the tests. So this makes it possible to do two things. First, you kind of, is it collapsed? It is. Oh, you found it. Excellent. I can't use IntelliJ intelligently. Ha! Thank you, Clemens, Tristan, and Sven. Thank you. So what did I do? I created the API call wrapper who has these things here. I've also generalized it not to use just the calculator programs object. I'm now passing in object, so it can be used by other things as well. And my tests don't have all the other platform things now, and they calculate calls the call wrapper with post with body. And again, what I mentioned is that these things, the application language stays here. All the other stuffs, the platform, the boilerplate, go here. And obviously, this is something that is more useful because you'd use these things over and over again for not just for calculators. So yeah, we found it. Everything's okay. Let's finish this because I'm probably late. So I showed you all kinds of examples of how to do minor refactorings to test that has a lot of impact of how we run it and why we do that, because each kind of refactoring takes a bit more meaning if we know what to look for. And finally, we kind of contracted the guard class and methods. That the test class, I think, is 27 lines, something like that. Removed unnecessary comments, created better names, and used literals better. I haven't shown you an example, but sometimes when going back to the get user by ID example, if 17 is equal to 18 or something like that, I put it in a constant called any user. If not, I would put specific user or discounted user, something like that, that I would see that in the test. Marcel says, I would recommend using constructors over builders. That's possible as well. It really depends on what you're actually building. When you add a new element, the builder code stays compiling. That is true. Chain constructor requires you to review the test. So you create a constructor as a compilation step, let's call it. So it will make you think about what you're actually doing. And parameterized tests will work too. I don't like parameterized tests. Well, I can learn to like them, but this is a whole kind of session, but that's okay. So use literals better, and then you can smell all the clean tests you can want. What I want you to remember, we need to treat test code and production code with the same standards because we're going to get back in there again, and we want to save as much time as we can. And we need to think in this kind of in terms, not about principles, what makes code okay, but what do we get out of it? And most of what I tell you is about how to spend less time on things to understand them better and solve things. And this is why we need to concentrate on when we're writing tests, code as well, really. And that's basically it. If you want to find me, you can look at all these kind of links that's going to be there. Twitter is as easy as can be. Let me see if something was added in the check. If you have other questions, put in them right now. You mentioned to generate builders out of JSON resources. No, I mentioned building builders out, to support JSON resources. Usually, if you do things like code generation out of data, you can do that. You can take like Lombok or something like that. You can take steps to take less steps when you write things, but you can do a lot better when you get specific data that you want to build. You don't need like a specific setter for every field out there, but you need to be more specific what kind of builder you can do that, because the most generic builder, it's like generating things like Lombok. You don't need to do that. You can, but it won't save you that much code. Specific builders will save you code and time. Would you say using camel case in test names is bad practice, or is it personal preference between that and snake case? I move between languages all the time, so everybody asks me, why are you doing this? There's no good practice. Bad practice, the only good practice there is what you decide as a team. So if you do code reviews and your team say, yeah, I can understand that, it really doesn't matter what you're using underscores or not. If you have some kind of static code analysis that shouts at you if you're using too many underscores, that's probably a problem with the static code analyzer, but you have to live in some way. So you need to define the way that's going to be useful for your team. Johanna said, what do you recommend setting up your data for integration test? Setup method in each test class that results in a lot of code for us, and I haven't found a way that I'm fully pleased. I can't tell you what exactly to do without knowing anything about your situation. Test data management in general, it's like a big problem, right? So regarding where you put this, how you use it, where you find it, and so on. So I would probably think about who's using this kind of data. It's one test class, yeah, it's going to be there. If it's going to be used for different classes, maybe use a base test class for like loading it. Maybe use a separate data loader to load it. You have different options, but it depends on who is using, how many objects are using this data, how many tests are using this data, and what's the difference between the modification you want to do between them. That's a whole kind of talk, I think. In this first version, local was about 100, and first version it's about the same. Yeah, I moved it around. Remember, there's a psychological impact on when we're seeing a very big type of code and seeing the same thing spread over multiple classes or multiple files. And the psychological, it's really there. So how am I going to read all this and understand this? And this kind of thing actually impacts the way of us understanding. It will take us more. So number of code lines, yeah, it didn't change much, maybe even got bigger because we have like more things repeating, like test class names. But the impact of that, of us understanding, is a lot larger than we think. Oh, not falling, I think, in the first one, therefore reusable. Yeah, okay, thanks, you're welcome. Totally agree, it's better code. I just wouldn't make the case for not the number of kind. I know, but it's something that I mentioned because then people look at it at the end and say, ah, but this, you lied to us. It's the same number of lines. And remember that everything I showed you today really doesn't matter unless you decide that as a team, this is how you're going to agree what clean is. So you need to decide what works for you, what makes better, what is in excess for what you actually need, and then decide this is our standards. This is how we look at our tests, and this is how we review tests, because of course you do review tests from now on, and stick to that. And as a team, you'll work better and save more time. If you don't have anything to say to me in my face, thank you for coming for this session today. And if you come up with anything, you can find me on Twitter. And if you want to come to the webinar, 3D Legacy Code next week in Java, which is going to be cool. Follow me, there's going to be this. Go to LinkedIn, find me there, and go on. And that's basically it. Thank you very much. Have a great day.